Well, good afternoon. My name is Michael Whiting. This is my project on quantum computing and its impacts on cybersecurity and computer science. Why is this topic important in 2025? Rapid advancements in quantum computing are having an impact on sectors like defense, finance, and artificial intelligence. To defend systems against threats at the quantum level, cybersecurity must change. Governments and international IT companies have already made investments in post-quantum encryption. What is my topic and how it is related to tech advancements? Instead of using classical bits, quantum computing employs bits which have the capacity to exist in many states at the same time through superposition and to become connected through entanglement. This implies that unlike conventional machines, a quantum computer can investigate numerous potential answers at once rather than processing them one at a time. These characteristics allow quantum computers to tackle some classes of problems exponentially more quickly than classical computers. For instance, a quantum system significantly simplifies processes like calculating numerous prime numbers, modeling molecules, optimizing complex systems, or scanning massive databases. New fields of cybersecurity, such as quantum key distribution, also known as QKD, or post-quantum cryptography, which is known as PQC, are developing to counter these threats. PQC creates novel mathematical encryption methods that can still function on conventional computers and are impervious to quantum attacks. QKD increases the security of communication channels by using the principles of quantum physics to generate encryption keys that cannot be intercepted without notice. Professionals in computer science and cybersecurity must comprehend quantum computing since secure hybrid encryption models and quantum safe protocols will be necessary for future systems. My first article is called Quantum Computing and the Future of Cryptography. The author is N. Samantha. This is the summary of it. The article describes how the most popular encryption schemes in use today are at risk from quantum computing. The majority of digital security relies on tasks like factoring very big integers that are challenging for traditional computers. Because Shor's algorithm can factor numbers exponentially quicker, it is seen as significant breakthrough. Because of this, encryption techniques like elliptic curve cryptography, ECC, and RSA are susceptible to quantum assaults. Since sensitive domains like online communication, government security, banking, and medical records could be compromised. This is continued. The post-quantum cryptography initiative at NIST which is developing new quantum safe algorithms is one of the example of how the world's preparing for these threats. All right, allergies. The goal of these new encryption techniques is to safeguard data even in the event that quantum computers surpass existing systems in power. According to Samantha, in order to prevent attackers from harvesting encrypted material today and decrypting later, the transition to quantum resistant encryption must occur immediately. The essay highlights the necessity of educating the upcoming generation of cybersecurity experts. Students need to comprehend new encryption models, quantum dangers, and how to secure systems in the future. This is how it relates to the topic. Directly relates to how cybersecurity principles are disrupted by quantum computing, backs up the idea that post-quantum cryptography is necessary for security in the future. Article 2, how tech firms are tackling the risk of quantum computing. The author is S. Torkington. According to the report, modern encryption protocols, which safeguard practically all digital communication, are seriously threatened by quantum computing. RSA and ECC are examples of modern security solutions that rely on mathematical puzzles that traditional computers require years or even centuries to solve. However, Shor's algorithm can address these issues quickly on on a quantum computer, making it simple to crack existing encryptions once large-scale quantum systems become accessible. This implies that private messages, government records, financial transactions, and health information might all be encrypted in a matter of minutes rather than decades. The global movement toward quantum safe encryption is highlighted in the article, particularly the efforts spearheaded by NIST to develop new post-quantum cryptography (PQC) standards. Long-term data is safety is ensured by PQC algorithms' ability to withstand attacks from both classical and quantum computers. The Harvest Now decrypt later threat in which attackers grab encrypted data now and wait for quantum power to rise sufficiently. The crack is also covered in the essay. As a result of all this, rather than waiting for quantum computers to reach their full potential, enterprises must start making the switch to quantum safe systems right away, ASAP. This is how it relates to the topic. It demonstrates how business leaders are responding in the real world, and it then demonstrates the need for corporate innovation and cybersecurity to flourish together. Article 3, title Quantum Computing and the Future of Cybersecurity. The author is the National CIO Review. The essay really discusses the benefits of quantum technology and how it might improve cybersecurity. One of the most significant developments is quantum key distribution, QKD, or communication technique that generates safe encryption keys using the principles of quantum mechanics. Because the quantum state changes in the event that a hacker attempts to intercept the key, both parties are immediately informed of the breach, making QKD incredibly secure. According to the paper, quantum secure networks are already being tested by significant organizations like the military, government, intelligence services, and international financial institutions. These pre these preliminary ex experiments indicate potential for developing communication channels that are almost impossible to reach. This is the continued version. According to the paper, quantum computing has two effects on cybersecurity. It can both introduce greater security measures and generate new vulnerabilities. Quantum computers pose a hazard because they can crack conventional encryption techniques that safeguard national security, corporate data, and online banking. Hackers may be able to decipher protected data more far more quickly than traditional machines thanks to algorithms like Shor's algorithm. This implies that companies need to get ready for a time when the encryption used today cannot be secure. According to the report, government, businesses, and cybersecurity teams need to start preparing for a post-quantum future right away. This is how it relates to the topic. It affirms the dual impact of quantum computing, which includes both opportunity and danger, and it demonstrates how innovation can lead to protection as well. Article 4 is What is cybersecurity risk from quantum computing? The author is KPMG. According to the report, in order to be ready for future quantum attacks, governments, businesses, and IT enterprises need to start implementing quantum safe cybersecurity rules. It highlights that the majority of contemporary encryption methods are not built to fend off attacks from quantum computers. If businesses do not update their systems in time, they run the of experiencing serious security breaches as quantum computing develops. The post also emphasizes how urgent it is because important sectors like banking, healthcare, government, and cloud services have sensitive data that could be compromised. The article main caution is the advent of Harvest Now, the creep later assaults, which allow hackers to take encrypted data now and hold off on cracking it until quantum computers are strong enough. For organizations like hospitals, police enforcement, military networks, and financial institutions that depend on long-lasting encryption, this poses long-term hazards. The essay urges companies to start creating hybrid encryption models with blend conventional security techniques with post-quantum cryptography in order to counter these risks. This is how it relates to the topic. It explains clearly why cybersecurity teams should get ready now rather than later. And it emphasizes how crucial quantum safe development is to schooling. And this is my work cited, and it was a pleasure speaking y'all today about my topic.